is a your turn, so you're going to want to pause the video, try it yourself, and then come back and see how it goes. So determining the half-life of an exponential function. When diving underwater, the light decreases as the depth of the diver increases. On a sunny day off the coast of Vancouver Island, a diving team recorded 100% visibility at the surface, but only 25% visibility 10 meters below the surface. The team determined that the visibility for the dive could be modeled by the following half-life exponential function. A of x equals a naught 1/2 to the power of x over h, where a naught represents the percentage of light at the surface of the water, x represents the depth in meters, h represents the depth in meters where there's half the original visibility, and a of x represents the percentage of light at a depth of x meters. So I'm going to actually switch. So a of x represents the percentage of light at a depth of x meters. All right. So we're going to use this to help us color code our formula and the information. So x meters, so that's going to go here in this formula sheet, and we right now know that we are 10 meters below the surface. A of x represents the light at that, so at 10 meters we're at 25%, and that's our a of x. A naught represents the percentage of light at the surface. Well, we had 100% at the surface, so that's going to be our a naught. And our last one, h represents the depth in meters where there is half the original visibility. And our question is asking, at what depth will the visibility of the surface be half? So that means we have a naught equal 100%, a of x equals 25%, x equals 10, and my h is what I'm solving for. So we're going to throw that into our formula. So we're going to have 25 equals 100, 1/2 to the power of 10 over h. So when we're solving exponential functions, we don't like having things out front. So we're going to divide both sides by 100. And I know you may not like fractions, but fractions are going to make your life easier. So 25 over 100 is 1/4. You can always math practice in your calculator. And on the right side, we're left with 1/2 10 over h. So the only way we know how to solve exponential functions right now is to get a common base. So I need to think to myself, how can I write 1/4 as 1/2 to the power of something? Well, basically we want to focus on the 4, because 1 to the power of anything is never going to change. So in order to get my 2 look like a 4, I need to square it. So I can rewrite this left-hand side to be 1/2 squared. And of course we didn't do anything to the right-hand side, so we're just going to write that down. Now that I have my bases the same, we can cancel those bases and set our exponents equal to each other. Can't solve with my variable in the bottom, so I'm going to times both sides by h to get that h out of the bottom. So we're going to have 2h equals 10. Divide both sides by 2. We get h equals 5. Again, that only gets us part of our marks because this is a word problem, we have to write our sentence. So we would say at 5 meters, the visibility will be half the visibility at the surface. And that's what would give us our full marks, having our work and our sentence answer. So part B tells us that on another day, we have the same diving team has now noticed that the diving conditions were worse. They recorded that at the surface, we still had 100% visibility. So I'm following the same color code. And then we only had 3.125% visibility when we were 8 meters below the surface. And again, it wants us to solve the depth where the visibility will be half that of the surface. So we're once again solving for h. So a naught equals 100. AX equals now 3.125. X equals 8. And H is what I'm solving for. So we're going to plug this into our formula. 3.125 equals 100. 1/2 to the power of 8 over H. Alright, so our steps of solving are going to be the exact same as above. So first of all, we don't like having that 100 out front. So we got to get that out of the way. So I'm going to divide both sides by 100. Again, working with fractions is better. So on this side, we're going to have 1 over 32. Remember, you can just use the math frac button on your calculator. And this side is 1/2 8 over H. So again, our thoughts is how can I rewrite 1 over 32 as 1/2 to the power of something? Again, we just want to focus on that 32. So 2 to the power of what gives me 32? Well, that's 2 to the power of 5. So I can rewrite this left side as 1/2 to the power of 5 equals 1/2 to the power of 8 over H. So bases are the same. We're going to ignore those now, and we're going to say 5 equals 8 over H. So the quick way to solve these, so you don't have to do the multiply and then the divide that we did up here, is to do what I call the switcheroo. So you can see this 2 and the H just kind of switched places. 2 came over here and became our denominator, and H became what we were equaling to. So we're just going to have these two things switch places. So H is going to equal 8 over 5. If that way confuses you, feel free to do it like the other way, times both sides by H, divide both sides by 5. You'll end up with the same answer. Alright, so now we got to write our sentence. So at 8/5 of a meter, the visibility T will be half the visibility at the surface. There you go. Hopefully those your turns went okay for you. Alright, so this example is when we're going to use our graphing calculator to help us solve an equation. So the problem with this question here is I have a base of 7 and I have a base of 2. Well, if I try the thought process we've been doing, 2 to the power of what equals 7? Well, that's not going to be a nice number, because 2 squared is 4, 2 cubed is 8, so there's going to be a decimal of 1 point something. So when this happens, we're going to use our calculator to solve this. Alright, so I got my calculator open here. So the first thing we always want to check is we want to go to our stats plots, make sure it's turned off. We're going to go to y equals, make sure we clear out anything out of there. And we're going to just reset our window by going zoom 6. So these first 3 steps are just kind of what you do to clear your calculator and reset it for a new graph. Alright, now that we're all reset, we're going to go back to our y equals, and in y1 we're going to enter in the left hand side of our equation. So we're going to enter in 7 to the power of x minus 1. Then we're going to scroll down on the right hand side of our equation. We have 1/2 2 to the power of x plus 2. So we're going to put this into our y2 function. So I like to enter it the exact same way it's seen, so that I know that I'm entering it incorrectly. So to get this fraction button, if you didn't see that, I just went alpha and I hit the button beside it. If you have a slightly older calculator, you're going to hit alpha y equals, and then you're going to hit enter, and it's going to do the same thing. All right, then we're going to open a bracket, and we're going to have 2 to the power of x plus 2. So now we're going to graph that. So I can kind of see my intersection here. However, we want to make sure that it's very clear. So I can see that I have to move my my graph up, which means I need to change my y value. So I'm going to go into my y max, and I'm going to make it bigger, say 15 or 20, and we're going to regraph. Now I can clearly see that intersection. Once we can clearly see that intersection, we're going to go second calc, and we're going to find that intersection. We're going to go 5. Then we're going to hit enter, enter, enter one more time. And of course, in our question, we have x's. So the answer is the x value, not the y value. In this case, we don't care about the y value. I just want to know what x is. So we would say that x equals 2.11 if we round to the nearest hundredth. And any equation can be solved this way. Sometimes finding their graph is harder than actually solving algebraically, so use at your own discretion. If the question says solve algebraically, you can check using this, but you have to show your work algebraically in those cases to get full marks. There you have it. So this is our homework. So you're just going to work on these. Again, when it says expressing both sides with the same base, that means you're going to do these algebraically. And this one you can use graphing technology, so that's where you can do these steps here. And then there's just a couple of word problems for you. Have fun!